presentation. So this follows from the yesterday. So just quickly, yesterday when we were talking about the image processing, we were saying is that what is you see on the top is what the image processing looks like, whereas at the bottom is how the human beings perceive the information. Then brain does the processing and gives the output, whereas in the imaging system we basically are replacing the eye, human eye, with a camera or an image sensor, which could be many type of camera. That could be thermal camera or infrared or X-ray, and then computer does the processing and output is the results. So in this case, the result being the red apple, because it's basically looking at that object. And then also we looked at this system as an example of how you would acquire the images by placing the objects on a platform, which then properly illuminated, and then you take image with the camera and process the computer. So then moving in the acquisition side, as we talked yesterday briefly, it is the first step which has to be performed, and it can be performed by a single image sensor, which means so you only have one sensing element, and that means if you scan the image, you would have to go that from top left corner to the bottom right corners, almost scan one at a time. So single sensor would take a long time to acquire the image. So you can have a single sensor. Typically those are photodiode, which reflects to the intensity or reflected light which is being received by the photodiode. It gives the appropriate signal or corresponding signal, which then can be interpreted for each pixel or each point on the image. But very rarely nowadays nobody uses a single sensor. Typically they would use is a sensor strip, which could be in line arrangement. That means the multiple sensors are arranged in line. So that's where line scan camera comes in, and then you take the one line at a time, and as either the sensing element would move or the object would move, and the related motion gives you basically the two-dimensional picture. And the sensor arrays are where multiple sensing elements are in the two-dimensional array, and take the picture of the object, and you basically get the two-dimensional representation of the image. And those are typically on the charge coupled device or the complementary metal oxide sensors. But also we talked about that you can take images in X-rays, using X-ray thermal cameras or high spectral cameras. Okay, so what is then image? Some of us we talked about that. What happened? Oh, okay, just lose connection. Okay. So image is for a black and white image. So if you were looking at black and white image, it basically is a spatial representation of an image along the XY coordinates, and it is a function of XY. So the magnitude or magnitude of that function at every point basically gives the gray value. So it is a 2D function where XY represents the spatial coordinates, and the gray level denotes the image intensity, or the value of the f at any point denotes the intensity. At amplitude is basically defined, amplitude f at any point defines the gray level. Now gray levels, typically gray scale ranges from 0 to L, with 0 denotes pure black, and L denotes white color, with the intermediate values being as the gray values. So when we are dealing with the black white image, typically those edges are, or the sensing elements edges are 8-bit, which means that you can have 2 to the power 8, which would be 256. So if you start with a 0, you can go up to 255 gray levels. So you can have basically 255, 256, 0 being the starting value. Different gray levels if it is a black and white image. If you have a color image, you have the same. Typically color images are 24-bit and 8-bit allocated each of the red, green or blue. So you would have again 256 levels in green, 256 levels in blue, and 256 levels in green. Okay? And the picture elements are all the pixels. And I think I have another slide which will show you how the then images are represented. Why it's moving. Something else loose. Let me see this one if that works. No. Okay, it's something moving. So it's just this one moving? Oh, that's just here then. Okay. Just a second. Yes. Come on. Okay. No, this one. So this arrow is not working, eh? Yeah, it's working now. It's working now. Oh, good. We are back. So every element of the image is all pixel. And so when we talk about do the integration over the whole image, we are talking about integration over number of pixels you have in the